project for testing purposes, then we can easily end up with millions and millions of files. And those are in particular many small files in a single simulation. Sergey also talked about that there one always runs the risk of a simulation job being cancelled because one gets over the inode limit. So that is what the user looks at. What is there the idea from the operator who runs cluster? I can talk a bit about how we do it in Göttingen. There, our main file system on which simulation should be run, the Scratch or work file system, that is based on Lastre. And Lastre just has a completely different pattern compared to the traditional OpenFOAM. It is optimized for reading and writing a small number of large files. And of course there, we as OpenFOAM users creating many very small files, potentially millions of small files, that is a bit of a mismatch. Now, in the ExaFOAM project, the Adios two-based file format already solves that issue by largely reducing the number of files, if I remember the talk by Sergey correctly. And it also enables something which connects it more to the project I work in. Adios 2 also has different backend layers, transports, and engines. And this is where I believe what we are doing in our research project could connect to. Another thing which I keep a bit as a discussion point, maybe we can talk about it after the talk. Currently, we are all writing all the files to one file system. Maybe one could also think about that if I anyway have purge, right, it would make sense to write that just locally and then later on copy it to the parallel file system, which you generally have in a cluster. With that, here a bit an overview of how a parallel file system looks like. On the left-hand side, we have the compute node where we run all of our simulations. And unlike a traditional file system, which you have on your laptop, the metadata and the actual data is not necessarily on the same storage device. In fact, that can be also on completely different servers. So metadata would be file size, where on the storage device, in which blocks is the data, permissions, who is allowed to access it, and quite a when it was the last access time, when was it created, and quite a few more things. And now, when we have a parallel file system, that is usually split. On one hand, in the case of Lustre, we have the metadata servers, which just take care of everything which I talked about now. And on the other hand, we have the Lustre object storage servers on which the actual data is located. So now, if we make many, many small files, you also see it, for example, when you do downloading, then we create a lot of load here on the metadata server, because for every file we open, close, and access, the metadata server needs to tell us, okay, where is the data located? So if we now just, and despite, even if that takes very little time, if we have then potentially millions of files just by one user in one simulation, that can easily overload the metadata server. You can also see that if you, for example, do an SCP from the cluster to your own computer, if you do SCP with all the OpenFOAM files, will be much slower compared to if you first pack it in a tar file, copy that, and untie it again on your computer. And it's pretty similar to that. The set about the storage API, there we have different layers. At the top, we have generally OpenFOAM or foam extend. And then we have different middlewares, for example, HDF5, Adios, or MPIIO. And then on the system layer, we have the Linux kernel with the POSIX API, and below we have the storage system, and at the bottom, the physical media. Now, when it comes here for semantics, when to access what, in which order, all of that is pretty much defined up here. So it's semantic rich, but at the bottom, that's not really known. And one cannot use it for optimization. But the further you go down, the higher the performance predictability comes because you're closer to the hardware. So that just as a bit of overview. Now in the MCSE, memory-centric storage for exascale project, we have two example file systems, BGFS and IML by Fraunhofer, which is developed as part of the project. And we use their user space clients and wrap everything in something which should replace the POSIX API in the libio verbs. And we can connect it either directly via that library if the application code is modified, or any legacy app via either a preload library or a fuse layer, so just as a file system. With that, what are we proposing? We are actually proposing to replace, at least for our application here, the system layer by the semantic aware libio verbs API, and by that allow the optimizations potential optimizations like where to put the data. Also, as I mentioned, if you just need the data once, one does not need to put it. One can do a better storage tiering and also optimize the caching. So there is potential. For HDF5, I just wanted to give you an idea how HDF5 is below what you generally have in the API. At the bottom, you have the file system on which everything lives, or the hardware. On top of it is a virtual file layer. And above that is another layer, the virtual object layer, which could already directly map to the file system, or it goes via the virtual file layer. So basically, if we would look at HDF5 to implement the system, we could either do it on one of those two layers. And I will also discuss that in 2 more slides. The current file format, which you, I think, all know, is of course the ASCII format, not very space efficient, but does a good job. More space efficient, the binary format. We have also in the Plus version, the collated file format, which also helps to reduce the number of files. And other formats used, I also saw some function object which uses the HDF5 format. That's why I mentioned it beforehand. And the Adios file format, which was now implemented as part of the ExaFoam project. So if we say we want to integrate our new API to bring its benefits to OpenFOAM, I looked at which integrations exist so far. For the new Adios version, we have it directly in the code. Before, by Mark Olsen, there was a function object, Adios Foam, to integrate Adios in OpenFOAM. And one could also make it opaque in a way that one runs it as a preload library, or just providing a file system which is already using that API. So for OpenFOAM, it's completely opaque, just like the preload library. But that is what exists. And I believe there are 2 more options now which I want to look at to have to check out which is eventually the best to implement that new API. In addition, I already mentioned HDF5 and RDOS2, which also exists in some way or another in OpenFOAM. For HDF5, one could use the virtual object layer or the virtual file layer. In the next slide, about the content will tell you which one we are considering also now. And to implement it in RDOS2, one could either use their engine or transport layer. In the current case, I think this transport layer would be the more appropriate one. So what have we achieved so far for the current state? Here you see it flipped. We decided for the virtual file layer to actually do that integration. And we are currently working on writing also such a virtual file driver for HDF5. For the transport, we did not start with it yet, but we are also actively implementing right now the preload library and a fuse wrapper so that those three options are worked on, and hopefully by the end of this year, I can already also start some benchmarking. So it's already a start, but it needs, of course, also future work. The currently prototyped approaches need to be optimized and fully implemented. And then I would also like to implement the mentioned the methods which are currently untouched so far, and then do some benchmarking of the different implementations and hopefully present that to you next year in the next OpenFOAM workshop. And with that, I'm a bit quicker than I expected, but it's, I think, good. So we have some time for questions.